सो हे गाइज वेलकम बैक टू PTS CAD एक्सपर्ट। सो आज का वीडियो पुरानी सभी वीडियो से कम्प्लीटली डिफरेंट होने वाला है बिकॉज आज हम बात करने वाले हैं डायनामो स्क्रिप्टिंग लैंग्वेज की और किस तरह से रेविट आर्किटेक्चर के साथ में आप डायनामो का यूज़ कर सकते हैं और एक बेहतरीन रिजल्ट आप क्रिएट कर सकते हैं, वो इस वीडियो में हम डिस्कस करने वाले हैं। पैरेलली हम एक लाइव ट्रेनिंग भी शुरू करने वाले हैं कंप्लीट रेविट BIM के ऊपर, जिसमें रेविट में आप आर्किटेक्चर भी सीखेंगे, स्ट्रक्चर भी सीखेंगे और BIM भी सीखेंगे। ये कंप्लीट अपने आप में एक यूनिक सॉल्यूशन होने वाला है जिसमें BIM के साथ में आप किस तरह से डायनामो का यूज कर सकते हैं, स्क्रिप्टिंग लैंग्वेज का यूज कर सकते हैं, वो भी आप जानने वाले हैं। और रेविट के अंदर स्पेसिफिकली BIM पे इसमें हमारा पूरा फोकस रहेगा। तो अगर ये ट्रेनिंग आप डिटेल में सीखना चाहते हैं तो इस ट्रेनिंग का लिंक आपको डिस्क्रिप्शन में मिल जाएगा, वहां से आप जरूर इसे एक बार चेकआउट कर सकते हैं। और आज की वीडियो कंप्लीटली इन डिटेल होने वाली है कि किस तरह से मास मॉडलिंग प्लस में स्क्रिप्टिंग लैंग्वेज डायनामो को किस तरह से कोलैबोरेटिवली यूज करके आप एक बेहतरीन रिजल्ट जनरेट कर सकते हैं। तो ये वीडियो बहुत ही इंटरेस्टिंग होने वाला है, इसे लास्ट तक जरूर देखिए। और अगर आप हमारे सभी कोर्सेज एक्सप्लोर करना चाहते हैं, डायरेक्टली प्रोफेशनल से लाइव ट्रेनिंग सीखना चाहते हैं, तो हमारी मोबाइल एप्लीकेशन PTS CAD एक्सपर्ट के नाम से गूगल एंड्रॉयड से आप डाउनलोड कर सकते हैं और उसमें सभी फ्री और लाइव कोर्सेज आप एक्सप्लोर कर सकते हैं। सो बिना देरी किए हुए चलिए वीडियो शुरू करते हैं।
Taking one step forward, this session of Revit will be all about introduction to conceptual massing environment, pattern-based families, adaptive components, and yes, of course, the end possibilities one can explore working with scripting language, visual scripting language Dynamo, a plugin of Revit. So welcome back to PTS CAD Expert and myself, Architect Kumar Kapadia from the city of Surat. And without wasting a single second, let's quickly jump into the interface of Revit. So to start with conceptual massing, while in home screen of Revit, let's open a new architectural template. Browse and in templates, English Imperial and default. So by opening this template file, it will open the default project environment of Revit. And from here, I will show you the various different approaches you can get to the massing conceptual mass environment. And the first and the foremost is by clicking on massing and site. If you click in place mass, it will give you this dialog box will pop up showing that Revit has enabled show mass mode, and so the newly created mass will be visible and mass 1, and it opens up the mass environment. Another approach is while in project template, if you click on component and if you click on model in place and you navigate to mass and it will say mass 1, that will also open the same work environment. The last but not least and my preferred option is while in home screen of Revit under family section, if you click new, it will navigate to this folder, and if you have your libraries extracted properly and in English Imperial folder you have all these template files, and in this you open up this conceptual mass and open up the mass template. So all of this different approaches opens up the same work environment, and we have the same tools for modeling purpose, but it is slightly different from what we used last time. Let me open up real quick and show you. There is new family and family templates English Imperial, and this is the template file generic model which we used last time. And the difference here is that you can model a 3D element using this template, but it has this 3D drafting commands which we used last time for modeling a 3D parametric door. But today we are going to explore this conceptual mass environment, and I'll show you that how that 3D drafting tools can be used in this environment, which is visually also a bit different. That is, you can see that the foreground or the background has this typical gray gradient, and it has the reference planes, that is the center, front, back, and left, right connected to it, and reference levels. Eventually, both the template files does the same thing, that is modeling a 3D element, but they do so by using different approaches. That is, in mass environment, you have model-based forms using model lines and reference-based forms using reference lines. So to use this tools, I will set plane, and when I click a line, you see that it by default selects the model line. And if I draw a reference line, and if I get closer, you can see that the model lines are black in color and are a bit bold. Then the reference lines, which are a bit thinner and purple in color. Another distinct feature than color is that when you hover your mouse onto this reference line, they have the integrated work planes connected to it, onto which you can actually model a 3D element and host a 3D element. And when you model a 3D element using the model lines and load them into the project, they are visible, whereas the reference lines are not visible in the project environment. So despite the subtle and negligible differences, both these lines does the same thing, that is modeling or hosting a 3D element. Now the 3D commands that we have in generic model template files, we don't have it here, but how do we do it in this environment? And that I will show you. So let's click on this rectangle, and by default it selects the model category, and by going to the set plane, I'll pick a plane and I'll draw a rectangle onto this, and now I'll just click this rectangle and drop down a solid form, and you see it creates solid form that can be edited and that can be elevated to a specific height. So this was about extrusion. Now blend. For that I need to create one more level, and yeah, it's already there. If not there, then create and levels, and from here you can drop a level. And now I will set plane, and I will click this plane and go to top and draw a rectangle onto that, and from here I'll set plane, and placement plane I'll select level 3, and there I will draw a circle. So both of these elements are on different work planes. So if I select this and then this and go to create form in solid form, so it will create a blend. Now let me show you sweep. So I will say spline through points, and I'll set plane, and I will draw a spline through points on that plane, and then I will I'll select this point and I'll draw a rectangle. And sweep is something which references a profile along the entire path. So I'll select this rectangle, I'll select this path, and I'll say create form. So there it is. Similarly, we can also do a sweep blend. So how is that? So again, reference line, spline through points, and I'll set this plane and I'll draw a spline onto that. But this time I'm going to say set plane. I'll pick a plane and I'll draw a rectangle onto this. And for a blend, I will say select this point and select a circle and draw a circle onto that. And now I will select this and the circle, and there we go. Yeah, so this was sweep blend. That is, it is referencing two different profiles at either ends. Okay, so this way you can create 3D elements in the mass environment, which is completely different method than what we saw in generic model template file. Again, you can furthermore edit this 3D forms and manipulate this. Let me show you how. So I'm going to select this reference plane. I'm going to draw a couple of reference plane, copy to say
25 feet on this side. Again, copy 25 feet on the other side. And I'm also going to make some reference plane here, 25 feet. Okay, CEO copy and 25 feet here. Yes. And now I'm going to set plane, pick a plane, go top and rectangle and draw a rectangle onto that. And I'll select this rectangle and I'll say create form, and I'll pull this arrow up until it snaps to this upper reference level. So how can you manipulate this 3D form furthermore? And what is the difference when you model a 3-element mass environment? So that is, you can select this individual faces and play around with it. For example, I select the top face. I can move it by pressing these arrows. I can play around with the gizmo, and also I can RO, rotate the upper profile a bit, and you have this twisted 3D element, the 3D mass element. And this ability is not there in the generic model template file, wherein you have to do everything manually. Also, this you can pull this up and you can press this arrow and make it slightly bent. And one more feature is that you can also select the edges and you can pull it in or out. And also you can make it up. And you also have these points on the end points of the edges, which also you can edit. Say you want this point a little bit up. And we have our organic, crispy, fascinating form. It's like that. What further can be done to this? You can select individual faces of this, and then you can divide the surface. Okay, no, not divide. First I will select this and turn the X-ray mode on, and it will show all the points varying from where it was created. And if you ever want, you can select this and add a profile. So I'll add a profile here. And now I can select this and drag it a little bit up, and you see this has formed a bend between this two top and bottom edges. The same way you can also pull and pull out this, and also you can select whole of this and say add edge. And you can add edges to this form, to the vertical faces, and automatically it adds, as soon as you add the edges, it adds this point and the line, which you can further manipulate and edit. So that is how it goes. And I will add an edge onto the front face, and now I will build up, and we have a 3D organic form. And I will turn off the X-ray. Now what can be done to this faces? For example, if I select this particular face, I can divide the surface. And I can add different patterns to it. For example, you see this is a triangular checkerboard pattern, and the rhomboid, and this is the rectangular checkerboard pattern. Yeah, but this is just a 2D piece of element which doesn't have any thickness or mass, and it is just a pattern. and how can we further edit that pattern. For that, I will go to no pattern, and we will have this grid, and I will edit this grid. And how I will do that? So by okay, so that is again a different file and different template file. So from herein I will open up this family, and by going to Imperial folder, we have this generic model pattern base, or the curtain panel pattern base. Both are one and the same, but the only difference is that when you schedule or quantify it, Revit will read this file as generic model and this as a curtain panel. So for now, I will open this generic model pattern base, and it will open up this grid with the 4 adaptive points. When you click on the points, it will say 1, 2, 3, 4, and this green thick lines, which are the reference lines. So when you click this pattern, when you click this grid, so and again drop down, you have the same list of different patterns which I just showed you, but that pattern is just a 2D element, and if you ever want to build thickness to it or design a parametric element, you have to open up this curtain panel pattern base family, and then by selecting this reference plane, you can just create form. So this is the form which is stuck to this grid. So we are going to get rid of this 3D element, and we are going to actually model a 3D parametric element, constraining it and dimensioning it, and assigning various parameters to it. So let's start. So first I will say set plane, and I will dimension it from here to here, 10 feet, and similarly set plane, and I will dimension it from here to here. I will call this, I will make this temporary dimension, permanent dimension into a parameter, and I'll say this B. I'll turn it into instance and a reporting parameter. Reporting parameter because I want to report it back to the host family, wherein whatever size we change to the grid, that this will adapt to it, report back to it. And this I'll change to A, an instance and reporting parameter as well. Now I'm going to create, and I'm going to lay a point on this. And when you select this point, it says the normalized curve parameter is something. A normalized curve parameter with a point is something that divides a segment from 0 to 1. So if I want this point exactly in the center, then this normalized curve parameter should be 0.5. And you can also place it directly when it highlights this little icon saying that this is the midpoint of the line. And I will place it here, and I will place it center. Just let me check that whether I missed it. Yeah, no, it's 0.5. And now I will select these 2 points and spline through points, and is a reference line. And I will select these 2 points, spline through points, and is a reference line as well. And now what I will do is simply lay the point onto this, and I will select this point, and I want to be on the intersection point of both of these lines. So I will say host point by intersection, and I will select this line. Now I will set plane, and I will select this plane and draw a circle, and I will turn that into a reference line as well, and I will make this temporary a permanent dimension, and select that dimension and make it a parameter where R, an instance parameter. And this time I'm not going to make it a reporting parameter, and that's not needed. Open up this family types open up this dialog box, and we have this parameters here, and I'm going to add a couple of parameters. The one is the max R, that is maximum radius, and another is another is minimum, and that as well an instance parameter. Minimum is, this is leg A and this is leg B, and whatsoever is the length of this both the lines in the host family, I want to find the minimum, and so I will just type in that minimum should be, if A is less than B, then I want Revit to choose length A, or let it be length B. Yeah, so that will be minimum. So right now both are 10 feet, 10 feet. So the minimum is 10 feet. And the maximum radius should be minimum, whatever is the minimum length Revit decides, that divided by 3. So that is 4 inches. And in the R, I will try that I want the radius to be maximum radius. The reason behind doing all this, instant parameters cannot be used in type parameter formula. Okay, so I will, I need to change this max R into an instance parameter, since I want to use that as a formula for radius. So this R radius will be equal to maximum R, and apply, and okay. The reason of doing all this jugglery was, the only reason that was that I don't, whatever is the length of this leg or this face or this face, I don't want this circle to reach up to this edge. So now by selecting all the reference planes, I will just say create solid form, and it will create the solid form, and I will change the dimension to 6 inches, and then I will create the wireframe and select this and say wireform, and I'll select this, and I want positive offset to 3 feet as well. Yeah, and there we go. We have this family which we can now host on to that family. I load this into this, and by going to 3D, I'll just select this rectangle which says no pattern, and I'll just drop down, and now under rectangle we have this family 14 which we just made, and I'll select that. Yeah, and we have this rectangular pattern onto this face of the mass. Yeah. Now, how can you further change it? If you want grid rotation to be 45 and say 45. Yeah, there we go. Now, this same thing can be done in the other way. Let me select this face and again divide the surface. And this time I'm going to say file, and I'll click new and say family, and this time from the English Imperial I will open up this file saying generic model adaptive. Yeah, and I'm going to create something similar that we did here. The same family I'm going to create, but I'm going to show you that what is the purpose of doing that in adaptive family and what is the difference. So adaptive family is made by using adaptive components. That is, if I set and place a points 1, 2, 3, 4, and now when I select this and say make adaptive, So it has this number 1, 2, 3 and 4. And now these are the adaptive points. The reason behind using this family and making this points and adaptive points is that I want to create a generic freeform pattern. I'll show you that how is that done. So I'll select 1 and 2, spline through points, and we will exactly follow the same steps like we did for the curtain pattern based family. Oops, sorry. 3 and 4. Spline through points, and there's a reference line. 1 and 4, spline through points, and there's a reference line. And again, we are going to lay a point on the face of this line, all the 4 lines, and I will select the center of that. I think I missed the center of this, yeah, so 0.5. And again, I'm going to select both of this, spline through points, and turn it into a reference line. Spline through points, turn it into a reference line, and host a point onto this, say host point by intersection, set plane, circle, and I will create this, and I will turn that into a reference line as well. And I will say this, oops, yeah, and I will make this a parameter, R instance. Yeah. And now I will set plane, and I will dimension this, and I will set plane, I will dimension this, and I will change both of them into the parameter. I'll say this B and reporting, and I'll say A instance and reporting parameter as well. And now I can just select this, create form, solid form, and I want it just to be 6 inches. And go to wireframe and create form and void form. I'll click this, 5 feet positive offset. There we go. So we have created the same family eventually which we did for curtain pattern based adaptive family, but the difference is that here it is hosted by this adaptive points, and it's like a free form and can adapt to any size or shape. See, you can drag this and make it however big you want. And just one last thing we need to do is that going to family types, we again want to make 2 more parameters. That is, one is max R instance, and we don't need to make it a reporting. One more parameter, that is minimum instance parameter as well. So for minimum, I'll type that if A is less than B, then I want Revit to select A or keep it B. So the minimum is 23 feet, and the maximum radius should be minimum divided by 3. So that will refrain the circle from going to the extreme end corners. And R, I will say max R. It's exactly the same process, but I will show you that what is the difference. And now this is family 15, and I will load that into the project. And now you see, unlike pattern-based families, in this we have an ability to lay this family manually. So that was the difference I was talking about. So how can you lay this adaptive family? So by clicking surface, I can just click surface pattern and nodes, and okay, so that will turn on the nodes of this on this grid onto which you can lay that particular family. That is the generic model, and it was family 15. Let's just drag that here, and now you need to lay that family. But just what you need to take care of this, that it has to be 1, 2, 3, 4, and it has to be laid in the same order. If you don't follow the order, then you will end up into errors. So I will delete this. I will say family 15 and drag, and 1, 2, 3, and 4. Again, you can be creative in your own way and place that. And you see, this way you can create your own pattern. And there we go, like this. And the fourth point, I will select this. So this is the way you can create a pattern of your own by manually laying this. So this was the difference between this pattern-based family and this adaptive components. So that's it. Again, what else can you do is that you can just select this, going to the level 1. I want to create 2 more reference planes onto this reference plane, plane 1 and 2, and I'll call this 1, and I'll call this 2. I'll name this 44. So I will set plane, and I will select this reference plane 1, or I can also pick a plane and just click this and go to south elevation, and now I can draw onto that particular plane whatever I want, and I will just create this freeform piece of line. And again, now I will set plane, and I will select plane 44 and draw a contrasting curve, exactly opposite curve to that we created earlier. And now I'll just go to 3D, and I'll select both of this and say create form. Yeah. So now this piece of sheet, this organic form, is acting as a roof for the structure, but it's not realistic, but it's just to show you. Also, we can add a piece of supporting elements to that particular organic sheet. And I will say placement plane, reference level 3. No, it doesn't allow me to. So here I will draw 2 circles, and level 3 and offset of 10 feet I'll give, so it will be visible. So I will draw 0 and a small piece of 2 circles, and then I'll go to 3D and it's created on reference level 3. So I need to select them both and move. I need to bring them up by unconstraining it and to this level. Yeah. And then I need to reposition them since, yeah. And what I'll do is I'll just say create form, solid form, select this and let it go all the way up until it touches that. So that's what a supporting element. Let me turn on this to shade it. Yeah. I'll pull this down. There it is. So that is it. So now let me open up this file and show you wherein I have also created this families, and you see it is the same family but a bit of different. For example, if you select this point, it has one reporting parameter as well, which the position of which if you change, that will eventually change the size of the punctures or the void within those panels. So that is it. Yeah. That is because this point is a reporting parameter and it's controlling the size of the punctures or the void within the circles. That is an extra feature which is added to this particular family. Also, this is an adaptive family which has been laid in such a manner that it appears to be like a pattern onto this piece of fabric. So this was all about adaptive components and curtain panel or adaptive panel, generic model pattern base or curtain panel pattern base, since both of them are one and the same. So one more thing which I wanted to show you is also an introduction to scripting language, wherein we can also create such designs which are more customizable and more editable, and we can have more variations and more options. So from Manage tab, you have to click on this Dynamo, and this will open up this interface, which is altogether a different working interface than what we saw so far. And here it works in totally different manner by calling out the nodes. And since this is a programming language, and I'll not go into the much detail of each and every node, and I'll be very precise and stick to the point, since this was just an introduction to visual scripting language, and if you ever want this to learn in detail, then you have to enroll for the course. So code 50 and Control C, and I'll create a couple of points. And I'll say this to be X, this to be X and Z, and this should be Z, and it creates the series of 4 points. So now again back to node mode and rectangle by corner points, then P2, P3, P4, and 1, 2, 3, and 4. And I'll turn off the preview for all these nodes since we don't need to see that. Patch, close curve, thickness, surface and wood block 0.5, boolean, false, and yes. Yeah, I will turn this off for now, and I'll create another point by coordinates. At this time I'm going to add a sequence 0 1 dot dot 49 dot dot hash n and call for integer slider connect this into n, x and z, 25 or 35, whatever. Turn the lacing to cross product and reduce this to 25 for now, and then node x times x goes to math random list, and x should be this, and times, and 20, what was 25, okay, delete this into 5, chop list and length, sorry, this should be in length and this should be number slider from 0 to 1, so the count of 0 dot 1 is very small, 0.25, and that goes into the Y. Flatten, now circle by center point radius normal, and I will say this radius should be this and normal should be y-axis, and see it has created the circles but very small, so increase this size. So this is the randomization which I was talking about. Again the same nodes, Control C, Control V, Control C, Control V. Turn this off and just have a look. Yeah, there we go. And this should be actually 1. Okay, difference all. surface thicken should go into the solid. And this should go into others. Oh, what's the problem? There we go. Preview off, and there we go. So now what is the difference is that now you can just play around with this as per your need. So you see the number of circle has increased and it has started even overlapping. Again, we will reduce the number by something like 15. Oh, that's too less. So 20. Okay. And also we can increase and reduce the size of the circles. So if I press 0.9, so you see the circles have got a bit bigger. We change it to 1. So that's it, and that's all for Dynamo.
So this was a pretty much very precise and short introduction to visual scripting language, that is Dynamo, the plugin of Revit. And of course the adaptive components, the pattern-based families, and conceptual mass environment. If you want to learn this in detail and explore the end possibilities, then definitely enroll for the course and join the course, and let's meet one-on-one and let's learn together and let's grow together. Best wishes for Revit. See you soon.